class. Today we're going to be doing section 2.6 in college algebra, which is combining and composing functions together. We're also going to be talking about domain restrictions of functions, what happens or how to find the domain of combined functions and composite functions. And the domain of the composite functions can get a little tricky. We'll definitely do that at the end of the video. So the first thing we want to do is just talk about domain restrictions in general. We're going to be looking at a couple specific examples of that. Here we have some polynomials, rational functions, and things with square roots. The two exclusions we're going to be focusing on is that we cannot divide by 0. So any x value that will make the denominator of our equation a 0 is going to be an exclusion or a restriction on our domain. Also, we can't have a negative inside of an even root. So if we had a cubed root, a negative would be okay. But if we have a square root or a fourth root, a negative inside that root is not okay. It becomes an imaginary number, which isn't included in our domain. We do imaginary numbers in this class, but only real numbers of x are going to be included in our domain. All right, so let's look at example number 1. We have f of x equals x squared minus 7x. This is just a parabola, nothing fancy. Domain is going to be all real numbers. In interval notation, and I'll just kind of do both notations here for a little bit. It would be from negative infinity to infinity. There's no x's in the denominator. There's no square roots, nothing weird going on here. Now on number 2, we have x's in the denominator. So all of a sudden we need to start thinking what values of x will make that denominator 0? And we need to take those out of our domain. So one thing we can do is factor the denominator. And I love factoring. Factoring is one of my favorite things. So fun. They're like little tiny puzzles that you get to solve all the time. All right, so we have x times x for x squared. Oops, not 3 times 3, 3 times 1 for 3. We have on a negative 3 and a positive 1 so that they add to a negative 2. Now, what values of x will make the denominator 0? Well, if x is 3, it makes the denominator 0. And if x is negative 1, it makes the denominator 0. So the way I'm going to write my domain is I'm going to say that x can be all real numbers except x cannot equal 3 or negative 1. To write that in interval notation is a little trickier. You kind of want to think about a number line. And I have negative 1 and I have 3. And I can't have a negative 1, I can't have a 3, but I can have everything else in the x's. And I can just put like arrows at the end. So now you have 3 sections of that number line, of that x values, and I can make an interval for each one of those 3 sections. And we want to go from left to right, lower to greater. So I would have the interval from negative infinity to negative 1, and then it stops. In union with, so in math we do this fancy little u, for in union with negative 1 to 3 in union with 3 to infinity. So these would be the 3 intervals that make up that domain. Now for my class, I don't care which format you use, just make sure to pick one and do it right. So whatever one you feel like is easier for you. In your next math classes, you may be asked to only do interval notation, so it's kind of nice to practice and see both of them. All right, number 3, we have a square root function. So again, we can't have the square root of a negative number. So I want my domain to be all values of x such that 3x plus 12 is greater than or equal to 0. Now 0 is fine. I have a little note here on the side. The square root of 0 is 0. There's nothing wrong with that. So it can be equal to 0. I'm just going to solve this inequality. 3x is greater than or equal to negative 12. Divide by 3, and x is greater than or equal to negative 4. There's my domain. And you can just leave it like that. If you want it to be an interval notation, I would have the square bracket from negative 4 to infinity because it can be equal to negative 4 there. And that would be my domain there. And you just pick one of those 2 formats. Now, number 4, we're kind of combining the things. We have a denominator with x's, so we don't want to divide by 0. And we have a square root. We want that to not be negative, which means in this case, this can't be negative or 0. And only because it's in the denominator cannot be 0. So I would say, okay, 14 minus 2x has to be greater than 0. It has to be positive. It can't be equal to it. Now I'm going to solve. So I'm going to subtract 14 to both sides. So I get negative 2x is greater than negative 14. And then when I divide by negative 2, if I divide an inequality by a negative, it switches my inequality direction. So x is now less than positive 7. So my domain can be like that, or I can write it as negative infinity to 7 with a rounded bracket. All right, let's move into combining functions. So we have f of x is 2x minus 1. G of x is x squared plus x minus 2. And then I'm just going to look at adding, subtracting, multiplying, and dividing these functions. So f plus g of x, it's the same as f of x plus g of x. And you can kind of see all of those written up here. So I'm not going to write them all out. So what I'm going to do is I'm going to take 2x minus 1 and I'm going to add it to x squared plus x minus 2. And then I'm just going to combine like terms. I'm going to write them in order in standard form. So x squared first plus 3x minus 3. And that's it. I'm just simplifying what that would be. All right, and then the next one, we have f minus g of x. Now this one's going to be a little more difficult and a little tricky. I want my f function, 2x minus 1, and then minus, and I want you to write it out like this the first time before you do anything with it. Write minus and then put it in parentheses, because what we want to make sure not to forget is to distribute that negative through. It's really important, and I want you to do that in 2 separate steps so that you don't forget. So I have 2x minus 1 minus x squared minus x plus 2 after I distribute that negative through, and then I end up with negative x squared plus x plus 1. And just checking my answer key, we're good. All right, f times g of x. So I have 2x minus 1 times x squared plus x minus 2. Some of my students really like organizing this in a box, and I like it too. I think it's a nice way to organize it. You can also just distribute it through and list them all out. But 2x minus 1 in the box would look like this, x squared plus x minus 2. And then we just multiply inside. So 2x to the third, we've got a 2x squared. We have a negative 4x. Don't forget those negatives. We have a negative x squared, a negative x, and a positive 2. Now, if you notice, our like terms are on the diagonals with each other, which is kind of cool. So when we rewrite it, I can combine those like terms, and I'll end up with 2x cubed plus x squared minus 5x plus 2. The box is a really nice way to organize that. All right, and then our last example here, f divided by g of x. So I'm going to have 2x minus 1 divided by x squared plus x minus 2. Now, the only thing I want you to do is see if you can factor that denominator and then check to see if any of those factors will cancel with the one in the numerator. Now, I already know it's not going to, because our numerator has a 2x, and in the denominator, we only have an x squared, but I still want to factor it. Show me that you've been thinking about it. You at least went through this process. So I have x times x, 2 times 1. I have a positive 2 and a negative 1. Now see if there's any factors in the denominator that'll match the numerator that can cancel out. There aren't, so I'm done. There's nothing I can do with this. All right, on the next page, we're going to start talking about the domains and looking at something that's a little bit more complicated here. So we have 2 square root functions. Adding those together, I would get the square root of x plus 3 plus the square root of x minus 2. Now, when we have the square roots, just note, if I have something like the square root of 2 plus the square root of 3, this does not equal the square root of 5. That is like a very, very not good thing to do. In math, you can't just add the insides of the square roots together. It doesn't work that way. So unfortunately, there's nothing we can do with this. That is the simplified form. Now, talking about the domain is a little bit more involved. What I would suggest you do for the domain is make a number line and figure out where your zeros are. And what I mean by that is what x values will make the inside of those square roots 0. So I know that if x is negative 3, it makes the first square root 0. And if x is positive 2, it makes the second one 0. Now we have 2 values to test out, and we have 3 sections to test out. So I'm going to kind of test all these different pieces of this number line to see where my domain is going to end up. So I'm going to first start by testing negative 3. What happens? Negative 3 plus 3 in the square root plus, and I'm going to plug it in the whole thing, negative 3 minus 2. I end up with the square root of 0, which is fine. That's just 0, plus the square root of negative 5, which is not fine. That is imaginary. So that is going to be a no, no, above the negative 3. Now let's test 2. So 2 plus 3 in the square root plus 2 minus 2, I get the square root of 5 plus the square root of 0. That's just fine. That is a real number. Nothing weird going on there. So that's going to be a yes there. Now I want to test values in between and on either side of those zeros. So 0 is in between them. That's a nice easy one to check. I can check the number 3 and the number -4. Let's check 0 first, just to see what happens in between. So the square root of 0 plus 3 plus the square root of 0 minus 2. Ooh, this doesn't look good. Okay, square root of 3 plus the square root of -2 is imaginary. So that's going to be a no. And most likely, based on this pattern of events, probably when I test -4, it's not going to end up with a real number, but I just want to be sure. So I'm going to plug -4 plus 3 in the square root, -4 minus 2, and this is just double bad. We get the square root of -1 plus the square root of -6, which is definitely not a real number. I mean, I love imaginary numbers. They're fantastic. They're really fun, but they're not going to show up in our domain. So that's a no. Let's check 3. So anything above 2, and let's see what happens. The square root of 3 plus 3 is just fine. The square root of 3 minus 2 looks like we're all set. I have real numbers here. So our domain is going to be anything from 2 out to infinity. So I'm going to write that in. Ooh, I didn't leave myself a whole lot of room. So domain is going to be anything from 2, including 2, to infinity and beyond. All right. So now that's all for combining functions. So that's like if we're adding, subtracting, multiplying, dividing functions. Now let's talk about composite functions or composition of functions or composing functions, however you want to say that. The composition of the function f with g is denoted by f and then this little open circle. In math, we say of here, so f of g, and is defined by this equation. So I really like this notation, but you need to know both of them. F and then the little open circle g is the same as f and then parentheses g of x. And what that means is if I'm taking g of x and inputting it into f of x, and we'll see this in an example. The domain here, we're going to talk more about this on the next page. It's pretty involved. All right, so let's look at these two functions. We have f of x is 3x minus 4, g of x is x squared minus 2x plus 6. And I want to do some composing of my two functions. So the way this is written, I have f of g of x. And a little thing I want to tell you about f of x is x, the variable, is just a blank. X can be anything we want it to be. So I can rewrite my f of x function. So if f of x is 3x minus 4, then f of blank is 3 times blank minus 4. And I can put whatever I want in there. Similarly, if g of x is x squared minus 2x plus 6, I can think of that as g of something, of blank, equals blank squared minus 2 times blank plus 6. And I can put whatever I want in there. So writing this blank format is going to really help us in these types of problems. So here, if you notice, my outer function is f. That's going to be this format here. So I'm going to use the f of x format equation to set this up. So f of blank equals 3 times blank minus 4. And I'm going to put g of x, the whole function g of x, into that blank. Ooh, I'm going to have to write kind of small. So x squared minus 2x plus 6. X squared minus 2x plus 6. I probably should have written a little bigger. That's all right. So I'm inputting g of x into the blank. Now we simplify. So I can distribute this in. I get 3x squared minus 6x plus 18 minus 4. So bringing that -4 down. Simplify 3x squared minus 6x plus 14. That's as simple as I can get it. That is what f of g of x is. Now going the other direction, so I'm going to separate this a little bit, g of f of x. So I'm going to, here, change my colors here. So the g function here is going to correspond to this g function. If I rewrite this as g of f of x, so g is that outer function there. So I'm using the g format. So let's write the G format as the blank thing. So G of blank equals blank squared minus 2 times blank plus 6. And I know I'm not leaving much room for number 3. I'll deal with that in a second. All right, and then I'm going to input f of x. So f of x was 3x minus 4. So that goes into all of these blanks, 3x minus 4. Now I just have some simplifying to do. 3x minus 4 squared is 3x minus 4 times 3x minus 4. And then I can distribute this in. I have a negative 6x plus 8 and then a plus 6 on the end. 3x minus 4 times 3x minus 4, I usually just use the FOIL method. So first, outside, inside, last. You can use a box to multiply those together if you want. So 9x squared minus 12x minus 12x plus 16 minus 6x plus 8 plus 6 from our other piece of our equation. Now we just have to add up all those like terms. 9x squared, negative 12, and negative 6 makes negative 30x. And 16 plus 8 plus 6 is plus 30. So that's what our g of f of x function looks like. Now, I'm going to just kind of do this here. Part 3, so I'm going to do number 3 down here, g of f of 1. So that means g of f of 1. We have a couple ways we could do this. Because we already did number 2, I could use the g of f of x function that I already have. I could plug in 1 in for x for the function I just found. But what if we hadn't done all that work yet? This is what I would suggest you do. So I'm going to just draw a little arrow here. I would suggest working from the inside out. So find f of 1. So 3 times 1 minus 4 is 3 minus 4, which is negative 1. Now replace f of 1 with a negative 1 and find g of negative 1. I get negative 1 squared minus 2 times negative 1 plus 6, which is 1 plus 2 plus 6, which is 9. Now I could have also used my g of f of x function that we found in number 2. If I did that, I'd have 9 times 1 squared minus 30 times 1 plus 30, which also equals 9. So you can do it this way, or you can do it that way. If you've already done all the work of finding g of f of x, then you can just plug your x in and go from there. All right, our last page here. Let's really dive into the domain of composite functions. And there's a little bit in the box up there, but I'm going to explain it down here as well. So first, I'm on the wrong page of my notes here. Okay, so first let's find f of g of x. So f of g of x, f of x is 2 over blank minus 1. Oops, not g, f of blank. So here's my f of blank function. I'm going to put g of x, or 3 over x, into that blank. Now, there's a short way and a long way to simplify this. We don't want fractions inside of our fractions, so that's what we need to kind of get rid of right now. But we're already at 18 and a half minutes, so I'm just going to show you the shortcut way. Let's see, I'm going to get a different color in here. The shortcut way is take whatever that denominator in the fraction that we want to get rid of here and multiply it to everything. So if I multiply that denominator 3 over x, if I take that x and I multiply it to everything in my equation, really, I'm just multiplying by x over x, which is 1. I'm totally allowed to multiply anything I want by 1 because it doesn't change it. But what happens, I have 2 times x on the top, and then 3 over x times x cancels out the x's, and I get 3. Minus, and then I have a 1 times x because I'm multiplying x by everything. So I end up with this, which is much simpler. There's no fractions inside the fractions, which is not allowed. Now, finding the domain is a little more difficult. So let's look at these 2 steps here. If I want to find the domain of a function f of g of x, the first step I need to do is look for any x's not in the domain of g of x, the input function. Remember, domain are your input values. We input g of x into f, so that's our input. So if x is not in the domain of g of x, then it must not be in the domain of f of g of x. So in this example, g of x is 3 over x, so x can't be 0 for that part of the function. And then the second step, any x not in the domain of our resulting function, f of g of x, must also be excluded. So f of g of x was 2x over 3 minus x, so x can't be 3, or it makes the denominator 0 there. Now notice, I'm not looking at what x values are excluded from just f of x. I don't care about just f of x because it was never an input. G of x was an input, and all the way around, the resulting function, x is our input. So we have those two pieces. So my domain here is all real numbers, except x can't be 0 or 3. All right, and then I'm not going to write that in interval notation right now. I'm trying to finish the video. I'm going to leave the next example for you to practice. Once you try it yourselves, which I really suggest you do, then check our filled in notes on the calendar and see how you did. The very last problem, I'm going to do example 1 here. We have h of x equals that whole thing to the 5th power. So lots of stuff going on. I want to express h of x as a composite of 2 functions. So what I mean by that is, what if h of x is f of g of x? I want to figure out what is f of x and what is g of x. So what are the 2 functions? So if I compose them together, I'd get this. So let's think about g of x first. G of x is like our inside function. So what is on the inside of h of x? Well, it's this whole thing, 3x squared minus 4x plus 1 is like the inside part. Now the outside part, think like your blank format almost. It's like something to the 5th power. So f of x is going to be x to the 5th power. F of blank is blank to the 5th power. And we put that g of x into the blank. All right, and then you guys can try example 2 and check the notes on the calendar. And that is it for today's lesson.